everyone, and welcome back. Today, we are going to build a fortress. Yeah, you heard me. Not with bricks and mortar, but with bits and bytes, right inside the massive world of Amazon Web Services. We're going to demystify one of the most fundamental services you have to know for any real-world job or AWS certification, the Virtual Private Cloud, or VPC. So get ready, and let's jump right in. So let's start with a big question. Think about it. AWS is this huge shared platform, right? You've got millions of customers, from tiny startups to massive enterprises, all running their stuff on the very same physical hardware. So the million-dollar question is, how on earth do you keep your important applications and your sensitive data completely walled off and secure from everybody else? How do you get your own private slice of that massive public cloud? Well, the answer is you build that virtual fortress we were talking about, a completely isolated network that belongs only to you. It's your own private corner of the AWS universe, totally sealed off. And in AWS, this fortress has a name. It's called a VPC. And I really can't stress this enough. It is the foundation for pretty much everything you're ever going to build and secure in the cloud. All right, so let's look at the official textbook definition. A logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you've defined. Yeah, that's a bit of a mouthful, isn't it? So, you know what? Let's just toss that jargon aside for a second and use a much, much better analogy. Just think of a VPC as your own private, gated community inside the giant, bustling city of AWS. And in this gated community, you're the boss. You get to decide all the street addresses. In the networking world, we call this the IP address range or the CIDR block. All that really means is you get to pick the private IP addresses your stuff will use, something like 10.0.0.0/16. You have total control over who gets in and who gets out. You're completely isolated from other AWS customers. And just like a real community, your VPC lives entirely within one city, or in AWS terms, a single region, like US East 1. So how do we actually build this thing? Well, here's our construction plan. First, we'll lay out the different neighborhoods, which are our subnets. Then we'll build the gates for internet connectivity. After that, we need a GPS to direct traffic. Those are our route tables. Of course, we need security, we'll talk about IP addressing, and then finally, we'll touch on some advanced components for connecting our community to other ones. Let's start at the top. All right, first up, subnets. This is a super important concept. If your VPC is the whole gated community, then think of subnets as the different neighborhoods inside it. This is where you'll actually put your houses, or in our world, your EC2 instances, your databases, all that good stuff. And here's a key takeaway. You never put a resource directly in a VPC. You always place it inside a subnet that is inside a VPC. Now, just like in a real community, not all neighborhoods are created equal. In the VPC world, we have two main types, and you absolutely need to know the difference. We have public subnets, which are for things that need to be accessible from the internet, like your public-facing web servers. And then we have private subnets for all the stuff you want to hide and protect, like your precious databases. The real difference between them, and we'll get to this in a minute, isn't some setting, it's all about how they handle traffic. And here's a concept that is absolutely critical if you want to build real-world, resilient applications. Every single subnet you create lives entirely within one single availability zone, or AZ. Now, you can think of an AZ as one or more separate data centers with their own power and networking. They're physically isolated from each other. So by creating subnets in different AZs, you can build an application that can literally survive an entire data center going offline. This right here is the heart of high availability on AWS. Okay, so we've built our isolated community. It's super secure, but it's also kind of a closed box. So what happens when our applications need to download software updates from the internet? Or what about when actual users need to get to our website? To let any kind of traffic in or out, we need to install some gates. We've got two main types of gates you're going to use all the time. First is the Internet Gateway, or IGW. Think of this as your main two-way front gate. It lets traffic flow both in from the internet and out to the internet. This is what makes a public subnet public. Then we have the NAT gateway. Now, this one is clever. It's a special, high-security, one-way gate. It allows your servers in private subnets to go out to the internet, say to download security patches, but it completely blocks anyone from the internet trying to get in. It's outbound only, and it is crucial for security. Okay, so we've got our neighborhoods and we've got our gates. But how does the traffic actually know where to go? When a little packet of data enters your VPC, how does it know which way to turn? Well, that's the job of the route table. You can think of it as the GPS or the traffic director for your entire VPC. It's just a set of rules, called routes, that tell network traffic exactly where it's supposed to go. Now, lean in for this one because this is a concept that trips up so many people when they're starting out. A subnet isn't public or private because of some little checkbox you tick. No. What makes a subnet public or private is the route table that it uses. Just look at the slide. If a subnet's route table has a rule that says, for any traffic trying to go anywhere on the internet, and that's what that 0.0.0.0/0 means, send it to the internet gateway, then boom, you have a public subnet. If that same rule points to a NAT gateway instead, it's a private subnet. The route table defines everything. Okay, our fortress is really taking shape now, but it's not totally secure yet. Just having gates and a GPS isn't quite enough. We need guards. We need firewalls that are actually inspecting the traffic coming in and out. And AWS gives us two really powerful, distinct layers of firewall protection. Learning how they work together is the key to a truly secure network. So, let's break this down carefully. First up, we have security groups. Think of these as a personal bodyguard for a single EC2 instance. They operate at the instance level, and they are stateful. That's a key term. It just means that if you allow a request to come in, the response is automatically allowed back out. You don't need a second rule for it. And they only support allow rules. Next, we have network ACLs, or NACLs. These are more like a security patrol for an entire neighborhood. They operate at the subnet level, and they are stateless. This means you have to create separate, explicit rules for traffic going both ways. If you let a request in, you have to add another rule to let the response out. And unlike security groups, NACLs can have both allow and deny rules. You use both of these together for that critical defense in depth. So, every single resource inside our VPC needs an address to talk to each other. But what happens when you need a permanent public address for your website that never, ever changes? So here's a classic gotcha that catches everyone new to AWS. You launch a web server, it gets a public IP, you point your domain name to it, and everything is great. But then, you have to stop and restart that server for maintenance. When it boots back up, poof, it has a completely different public IP address, and your website is broken. The solution is something called an elastic IP. It's basically a static, public IPv4 address that you reserve in your account. You can then attach it to any instance you want. It's yours, and it doesn't change. Problem solved. Okay, so we built a really solid self-contained fortress, and this is perfect for a lot of applications. But what happens as your company grows? What if you have multiple VPCs for different teams and they need to talk to each other? Or what if you want to access AWS services like S3, but without your data ever having to go out over the public internet? Well, for that, we're going to need some more advanced tools. Let's quickly run through three powerful components. First, VPC Peering. This lets you connect two VPCs directly together so they can talk using private IPs, almost like they're on the same network. It's a simple one-to-one connection. Next, VPC Endpoints. These are amazing. They let you connect privately from your VPC to AWS services like S3 or DynamoDB without needing an internet gateway or a NAT gateway. All that traffic stays on the secure AWS backbone. And finally, for huge organizations, there's the Transit Gateway. Instead of a messy web of connections, a transit gateway acts as a central hub, or a cloud router, that lets you easily connect hundreds or even thousands of VPCs and on-prem networks together. Now, theory is great and all, but let's see how all of these pieces actually click together in the real world. We're going to walk through one of the most common and important cloud architectures there is, a secure 3-tier web application. This is where it's all going to make sense. So let's trace the path of a single user request. Step 1. A user types your website address into their browser. That request flies across the internet and arrives at your front door, the internet gateway. Step 2. The route table for your public subnet sees that request and says, aha, I know exactly where this goes, and it sends it to your web server. That web server lives in the public subnet because it has to be reachable. Step 3, now the web server needs to do some work, so it talks to the application server, which lives safely in a private subnet. Step 4, that app server needs data, so it queries your database, which is tucked away in another, even more secure private subnet. And then, Step 5, the response flows all the way back through that same path. See the magic here? At no point were your application server or your database ever directly exposed to the internet. That is classic, secure, layered cloud architecture. Wow, we have covered a ton of ground today, from the basic idea of a private cloud all the way to the little components that make it a secure and scalable reality. Let's do a super quick recap to lock it all in. So let's review our VPC toolkit. The VPC itself is your private gated community. Subnets are your public and private neighborhoods inside. The internet and NAT gateways are your gates to the outside world. Route tables act as the GPS for your network. Security groups and NACLs are your layered bodyguards, and the elastic IP is your permanent, static public address. If you get these 6 components, you are well on your way to mastering AWS networking. Now, look, watching this explainer is a fantastic first step, but the absolute best way to make these concepts really stick is to get your hands on the keyboard. Log into the AWS console. You can do all of this for free in the AWS Free Tier, and just try to build it yourself. Create a VPC, a public subnet, a private subnet, an internet gateway, launch an instance, see if you can connect to it. Trust me, that's where the real learning actually happens. You now have the fundamental building blocks to create secure, scalable applications in AWS. You literally have the keys to your own virtual fortress. So the only question left is, what are you going to build? If you found this helpful and you want more deep dives into AWS and DevOps topics just like this one, make sure you hit that subscribe button. Thanks for watching, and I'll see you in the next one.